I'm going to go straight to the top questions. We've got questions which have been answered as well. So, Gwilym, thank you for that. But I'll take from both sets of questions, so both the answered and the unanswered ones. But by far the most popular question has been around window coatings. And this question was posed when Oliver was still speaking. So I think it's possibly people are really interested to hear from Oliver whether this is something which is popular in Spain. I think it's often seen as a bit of a quick fix. Keep the design the same, put a coating on the window. Is that the solution? So does window coatings to glass reduce radiant heat gains? Oliver, in your experience, what do you say?
Well, I understand that that's in relation to solar control and low E coating on the glazing itself, no? Yeah, I mean that's fairly standard around here, actually, and so it helps. But I don't think it's clearly not a solution to avoid overheating. It's and it's going to be there's going to be a penalty for winter gains. So I think if there's an overheating approach is based just on bringing the G value down of the glazing, I think it's not the right approach. But it can be useful combined with external shading, natural night ventilation, thermal inertia, and low internal heat gains, and so on.
Thanks, Oliver. Julie, I saw you smiling when that question was raised. Do you want to just expand on that a little bit from the kind of UK perspective?
No, I just completely agree with what Oliver was saying. So nodding enthusiastically.
Fantastic. Okay, the next sort of top rated question we have, let me just refresh to make sure I'm getting the most up to date ones. Yeah, so ceiling fans, do they have any impact on airflow rates from each inlet from the MVHR into rooms? I don't know who has the most experience with that. Lots of blank, no one's like jumping at it. So Oliver, you've got the most ceiling fan usage. So is that something that just come up as an issue?
No, absolutely not. I mean, they just move air around in the room, so it's separate to the airflows. As far as I'm aware, they're going to be supplying extract with the MVHR system, so there's not a conflict in any way, I think.
Okay.
I'll just add the short answer is no, I think.
Thanks, Alan. That's great. Okay, I'm going to jump across to some of the answered ones now because we've got another one which has been very popular rated, which is to do with retrofit. So it's not just new build we're talking about. Actually, when it comes to our existing buildings, that is a large part of the problem as well. So the question was about using air source heat pumps for cooling in retrofits. I don't know who wants to take that one. Gwilym, do you want to, since you've already had a shot of answering?
And I think the answer was, yeah, you can do it. I mean, a lot of the approaches that we talked about are, terminals that you could fit inside a room and an air source heat pump that can sit outside. I guess one of the bits to think about is the connection between the two in pipework routing, in that if you probably want your pipework, particularly if you're using lower temperatures to do the kind of the cooling options, particularly the fan convector ones, to get quite cold, then you want the pipework to be insulated and protected against condensation as well. So figuring out how fiddly that is to do is a bit awkward, or could be awkward depending on the routing. But in principle, yeah, I think it's doable. And if you're doing a decent retrofit, you should be getting the heating loads down to a point where a lot of the underfloor options, etc., are viable as well.
Thanks, Gwilym. I'm going to take this next question and ask Julie if you could answer it, which is to do with kind of future design liability. So someone was asking whether if we're just designing to 2020 weather files, are we potentially getting a liability issue for designers when we know that we're in a warming climate? What CIBSE's take or your take is on that?
Yeah, so the recommendation by CIBSE is to use future weather files, and there's recommended minimum future weather files to consider. So in effect, that could create a potential liability in the future if people were shown to have consistently ignored it. I assume the details will depend, but I think ignoring the purely legal side is pretty clear that not paying attention to this as a designer is not following advice from CIBSE and many other bodies. I'll stop here.
Thanks, Julie. So there's another sort of round of questions, and there's a sort of general discussion that's threaded through. So I'm going to link some stuff together now around thermal mass and about the importance of thermal mass for summer comfort, using PHVP as a tool to calculate thermal mass. Are there particular methodologies or tools? How important is thermal mass? So Nick, do you want to take a first stab at responding to the general topic of thermal mass and summer comfort?
Yeah, I think it's particularly in the UK climate where we don't really have an obvious summer start and end. We get 3 days of heat and you think bring it on, you let the heat build up, and then it's too late. So I think in sort of places, Spain, maybe you can use thermal mass more cleverly. People know to start ventilating at night. So it's a bit of a mixed blessing, I think. It can absorb the heat in the day, but we don't really have a culture of dealing with the build up. And if you don't deal with the build up, it doesn't help. And once you get into cooling, then it kind of, I think, becomes fairly irrelevant, because you're just giving a gentle level input of cooling. So yeah, I think people do get very it gets quite heated.
Gwilym, and then Julie.
Well, just 2 bits, I guess. One is, I think it's important not to have it as a kind of get out of jail card where people are like, well, although I have put in this tremendous amount of glass, don't you worry, because I've shoved a load of concrete in to give me thermal mass and make my design work. And I guess the other one was that, at least from a few projects when we've had a look at some data afterwards, even the what I'd initially thought would be like relatively thermally lightweight buildings have looked like the sort of temperature response has been closer to a kind of archetypal high thermal mass building, because I think they've been so well decoupled from short-term fluctuations in outside air temperature and things like that. So that's been quite interesting from my point of view, and then I guess gives you less of an incentive to think that the high thermal mass is useful. And I think it's a bit of a double-edged sword as well, isn't it? Because it hangs on to the heat for longer as well. So if you have got a bedroom or something you quite like to cool down at night, and you've charged it with a lot of heat during the daytime, then that's not a great situation to be in either.
Thanks, Gwilym. Julie.
Thank you. Yes, what I wanted to add is that issue of how you dissipate it, and I think it's quite telling that Gwilym is, with all your London experience, you're the one of the speakers who mentioned noise the most, because when we think about Mediterranean climates, there's always this, oh, but look, there's a lot of thermal mass, etc. But it tends to come from quieter rural situations with more diurnal shift. When we're talking about new housing in the UK, it's quite rare now that quiet, green locations is what we're talking about. So it's so contextual, and I think we should only ever talk about thermal mass with nighttime ventilation or with nighttime cooling, because otherwise it can really create a risk, as Gwilym was saying.
Absolutely. I mean, I have 2 young children, and sleep is still king in our house, and we often will not have the windows open because it's disruptive to their sleep, even if it's just, I live in the countryside, so sometimes it's just the birds, but that's enough to encourage us to keep the windows shut, so we don't always get the night cooling. Oliver.
Yes, just very briefly, I fully agree with all of that. I would just say, in my experience, thermal mass becomes a slightly religious debate. You either believe in it or you don't. I mean, I think in my experience, in particularly here in warmer climates, is basically the conclusion that some thermal mass is useful. I've seen lightweight buildings not overheat. I've seen heavyweight buildings overheat, and like Gwilym said, you get this radiator effect during the night, which is really unpleasant. But my conclusion is some thermal mass is useful, combined with a whole lot of other strategies.
Anyone else want to comment on thermal mass before I move on? I couldn't see whether Alan, you had your hand up, but it came down. Okay, we'll continue. Oliver, this is actually just because you've sort of, we're coming to you sometimes just because you've got this sort of more embedded experience. And one of the questions was actually like, is this universal? So do all designers on all projects consider overheating as a key design criteria in the same way that we would think about, heating our buildings in the winter? Because it's very much not the case here. Or is it still nuanced and not everybody's taking that kind of holistic approach?
That's a really good question. I mean, I have had debates with designers, clients, developers on some projects here in sort of the Iberian Peninsula, actually debating whether or not they need to put blinds in, you know. And you go to houses in Switzerland, for example, every house has an external blind on it. So it surprises me sometimes that here it's not that embedded as you would expect. So I think overheating is an issue for people. I think designers working in warm climates as it is anywhere else, and there's the same problems and the same tendencies are there, I think, which is overglazing, no shading systems, and a sort of free rein on those design aspects, and then just chuck lots of AC into it. I think we see that definitely as a feature in designing here. Obviously, people are more aware of higher temperatures and higher solar radiation in these kind of Mediterranean climates, but I would say it's not perhaps as embedded as you would expect.
Right. Well, it's interesting. I mean, when I knew that we were talking about active cooling today, I was like very conscious that I didn't want it to be all about active cooling as a solution that means we don't have to consider all of the more pragmatic passive cooling things first. So I was delighted to see that you started your presentation with that, because it just feels like that as we have these discussions more in the UK, yes, we have to learn about active cooling from you, but before you guys were doing active cooling, you were doing passive cooling strategies. So we need to make sure that we capture that first and then think about the bolt-on, the cooling. There's a couple of more kind of very specific technical things, which I'll pull out a couple of, but because those questions are always very specific and you think maybe they're project specific, we can't answer them all. There's been like there were over 40 questions at one point up on the board. And then I'll close off by asking each of the speakers just to share kind of a final thought from them or from their organization around the whole overheating and summer comfort in the UK. So here's one of the specific questions around the use of exhaust air heat pumps or compact units. So they're seeing an increasing use for both heating and cooling. It seems as though inputting them for cooling isn't feasible. Or is it that they haven't found the right solution? So that was a question specifically about using compact units for cooling. But it seems like in the discussion we probably have been putting that forward as a proposal. I don't know whether it's something that one of the UK team wants to pick up on. Alan or Gwilym?
Only as much as to say I think it is possible. I know you can model the compact units. I can't remember the exact details. There's a bit of fudging that used to be needed in PHPP for getting them to work, as well as being an MVHR unit. But so is this possible? I think the answer is yes. Exactly how you do it, I can't remember offhand, I'm afraid, but the manual is normally pretty good and the forum is quite helpful as well.
Thanks, Gwilym. There was another question which relates to the use of the cooling coils, the cooling the ground floor. Are there any like discomfort issues that are inherent to that residents experience and that we should be mindful of? Whether that's something you've looked into, maybe Alan, on the projects you've been looking at.
The discomfort with the floor?
Yeah, with the colder floor.
Not that people have reported. It's only a room temperature floor, basically the same room temperature you'd have in the winter. Like a 20-degree floor it's nice. I mean, my cellar has a 16-degree floor and I like that in the summer, but it gets condensation on it. Yeah, not discomfort, no.
Okay, I'm going to put one other kind of sort of general question. It's again a theme that's come through a few times, and this is to do with like material choice. There's a whole bit that people were talking about, like the decrement delay of material properties. Should that be considered when we're thinking about our insulation choices, especially for roof insulation? Does the material choice also, is that affected by the lighter surface colors? So there's a whole piece around material choice and how it's affected in the summer, and whether there's different considerations than we have normally when we're thinking more about the thermal performance of our buildings in the winter. Oliver, I don't know whether you want to kind of pick on that first.
Yeah, no, that's a really interesting question. There's obviously a lot of debate on this, I think. You know, is a wood fiber insulation in my roof going to keep me cooler than an XPS or a mineral wool or so on? I mean, I think I don't know the answer, because I think beyond the very simple calculations of decrement delay and so on, I'm not aware of enough empirical studies to really say this or that. I do have subjective feedback from some clients who have bio-based insulation in their roofs, for example, who say, oh, I feel it's much cooler, but you don't really have a control there, so it's a bit difficult to sort of nail it down. Obviously, from an environmental perspective and general ethos, of course, using bio-based insulations, I think, is always interesting and good to try and do. But I'm not sure how much difference it really makes as a single measure.
Thanks, Oliver. Alan?
We're going to talk about, discuss that in a bit more generally. So we're just talking about the fact that there's some thermal mass in the construction as well as insulation, and that sort of slows down the peak of heat going through it. One of the things is if you've got a U value of, say, less than 0.1 in the roof, there's not much heat going through it. And so maybe it doesn't matter too much. Something I came across in project in Tanzania actually was discovering that all thermal mass was bad, basically, because the sun shone in the day, you wanted to go to sleep in the night, and the thermal mass would just be keeping heat there. So if you get it wrong, you could be getting the midday sun down on your head in the bed in the middle of the night. And just a personal experience, our house has external insulation and 600 millimeters of stone wall. We have about 1.5 day decrement period in practice. So if the sun comes up and it gets really hot, you think the first night, oh, it's cool. And then the second night, you'll just start to feel a little bit of heat come through the wall. But it's the insulation is what matters, really. I don't think it's not a substitute for installation. So
that's great. I'm very conscious of time. I really appreciate that you all stayed on to get through a bit more of the Q&A. There's so many questions, we're not going to be able to get to them all. So instead, I'm going to just use this last few minutes just to ask each of you in turn just to share some closing thoughts just on the general topic. Maybe the key thing that you want delegates to take away from the day. So I'll start in speaking order. So Oliver, do you want to go first?
Okay, I haven't really thought about this, but I mean, I think the main conclusion in this whole topic for me is keep the sun out in the summer. That's the main and the best way of keeping buildings cool.
Thanks, Oliver. I realize this is one of those horrible things when actually you go around the room and then the person who's speaking last is like, everyone has already said it. So I'm going to change it up and now be like, actually, Julie and Nick get to go next because they've had the least time to speak. So Julie, over to you.
I thought I'd be last, so I'd prepared something that hopefully people wouldn't have covered. So I'd still say that. A question we do get more and more at CIBSE is the impact of these systems on embodied carbon. And there's no doubt that potentially it's not negligible. Some of these systems are quite complex. Obviously, there's the refrigerants. At CIBSE, we're doing quite a lot on the embodied carbon impact of systems. So if anybody is interested specifically in looking at cooling options in Resi, do get in touch. But a pet topic of mine, and I've discussed that a few times with Passivhaus people, is I'd really love to see an overall study with data on how the passive design measures have helped reduce the peak load and the sizing of the systems and therefore the embodied carbon. I think that's the missing piece. We hear a lot in the public about the potential increase in embodied carbon from a little bit of insulation, but we never see the proper, well-designed impact of passive measures on equipment size.
Yeah, that's great. Thanks. That's a really good point, probably for summer and winter actually as well. Okay, so Nick, over to you next.
I think building on what both Julie and Oliver have said about keeping the loads down as a comfort thing. So not just as some sort of like religious belief or it's more green to do passive measure first, but I think if you can calm everything down, then we can actually have summer comfort. We tend to talk about winter comfort and how lovely, and we're trying to avoid any cold surfaces and go to the nth degree about comfort in winter. Then when we get to summer, we just say, look, don't get sued because we overheated and no one died from a heat stroke. So if we can sort of apply that same sort of philosophy we do with Passivhaus in winter to the summer, I think it'll solve a lot of these problems. Yeah.
That's great. Okay. Right, Alan, you next, and then we'll finish, like Gwilym, bring up the last comments.
Okay, I'm going to say I'm sort of often find with the Passivhaus and the CIBSE community that we're kind of, for residential, challenging the status quo, is that the winter we have active heating systems, and in the summer it must be natural. You've got to demonstrate through expensive consultancy that you can't do it naturally. And in the old days, our houses were really leaky. They were naturally ventilated to 10 air changes per hour through the winter. We've now managed to successfully isolate them, building a passive house that is very isolated from outside, airtight, fully taken care of, ventilation and so on. And then you still want it in the winter, in the summer, to make it into an old-fashioned, free-running open building, when we could do it for possibly less energy and less capital cost as an active cooling building. We've certainly seen that in schools where people are putting in extra vents just for cooling at extra expense. And if you've already got the equipment to do it for very little energy use, then it's something to bear in mind.
Thanks, Alan. That's fantastic. And Gwilym.
Oh, great. Well, as
Someone
the
had to
cliche
have the hot
goes,
seat,
yeah,
so.
I already said my stuff on it. I think, yes, keep the sun out, avoid putting other heat into the building as well if you don't need to. Choose sensible passive design, but don't pursue pure nat vent as a religious crusade. And think about the future, including the weather, and make sure you're communicating clearly with the people who are either buying or going to use the building what they're actually going to get, so they understand it and are happy with it at design stage, not 3 years in the future.
Fantastic. Thank you so much, Gwilym. I am not going to hold anyone on anymore by giving any further thoughts. That was a wonderful way to round off the session, I think. And I just have to say thank you to all of our speakers and our 2 panelists today. And a huge thank you to all of the delegates, because we still have about 95% of the people on the call who joined the webinar earlier, because everybody was clearly as interested as me to stay right to the bitter end of the Q&A. So thank you, everybody, for being so supportive of our speakers and panelists by staying on until the end of the session as well. So on that note, I'm going to let the speakers and the panels turn off your screens and your microphones and just give you a huge thank you. You can now relax for the rest of the afternoon. Hopefully you don't have too busy a session going forward. So just 2 closing slides for you today. These are just some resources. All of this was in the resources folder, so please do download these links to the summer comfort statement, our keeping cool guidance, and also the dynamic thermal modeling guide. And on that note, I'm very pleased to close the session today. Apologies for running late. It's not like me, but I really wanted to give those speakers the full time possible for us to delve into all the detail of their presentations. And thank you, as always, to the Passivhaus Trust team behind the scene who make these sessions run so smoothly. And I wish you all a nice and relaxing Wednesday afternoon. Thank you very much.